one of the reason to study calculus is it gives us the ability to figure out maximum and minimum values of a function. And of course, a function model real life. So it's quite important to be able to determine for what values of, for say, x, f of x has a minimum and or f of x has a maximum. So I'm going to sketch a function here, something that looks like this. And this function has an endpoint, so it's on a closed interval. And we can see that it has valleys and peaks and different points that we'll be interested in. We probably be interested in, let's call this the first point on the left, x sub 0, and we'll give it a value of a. And then this point right here will be b. And since we have in the middle, we have other points of interest. For instance, right here, we have something we'll call x sub 1. Right here, we have something we call x sub 2. And here we have x sub 3. And so this will be x sub 4. And that would be b. So the function f of x, or y equal f of x, sit on an interval from a to b. And we're interested in particular at 5 points on this sketch, on this function. The 2 endpoints and the local 3 points that represent either a local minimum, which is x1 and x3, or a local maximum, which is x2. Now, why would we say that these points represent local minimum? Because if you're looking at x sub 1, for instance, the corresponding y value, the y value correspond to x sub 1 is the minimum in this area. Of course, we can go to x sub 3 and find even a lower value of y that correspond to x sub 3. So these 2 points with something that we call local minimum. Likewise, as I looked at x sub 2, I see that in this area, in the vicinity of x sub 2, there is no other y value greater than the y value correspond to x sub 2. So therefore, this will be a local maximum. The term local also, you can see the term relative. X sub 1 is a relative minimum, relative in this area. Actually, relative will be in comparison to a global or absolute. For instance, if I'm looking at the highest value of y, well, that will be correspond to the endpoint x sub 0 equals a. There is no higher value than this point. So this point, instead of local, we're going to say this is a global maximum or absolute maximum. So we can see that x sub 2 is a local or relative maximum because it's relative to this vicinity, to this neighborhood of x sub 2, but the highest peak, the highest value of y, correspond to x sub 0 equal a. Therefore, we're going to say this is a global maximum. So where is the global minimum? Where is the lowest value of y? Well, it will be the corresponding, the value of y that correspond to x sub 3. So here we have a global minimum. And there is no contradiction with the fact that at this point we have also a local minimum. It's local because in the vicinity of x sub 3 there is no lower value of y than the one that corresponds to x sub 3. But it's also the lowest point on the whole domain from A to B. So it's both local and relative maximum.